We're going to review your final exam practice from today, so feel free to skip forward to the part that you need, or if you think that you need to watch the whole thing, then you can do that as well. Our first slide asked us to find the number of solutions for each system. First, it says Harley graphs a system of equations and notices that the equations have different slopes and different y-intercepts. Because these graphs have different y-intercepts and different slopes, that means that they are both changing at different rates and starting in different places. At some point, those two lines will intersect with each other. Because they will intersect, they will only intersect in one place. That gives us one solution. Next, Jen graphs a system of equations and notices that the equations have the same slope and the same y-intercept. If they have the same slope and they have the same y-intercept, that means that those two equations are the same line. Because they are the same line, every point on that line is a solution to the system. And since every line has an infinite number of points, there are infinite solutions to that system. Next, Desmond graphs a system of equations and notices that the equations have the same slope but different y-intercepts. Since these lines have different y-intercepts, they start at different places. But because they have the same slope, they're always going to be changing at the same rate, which means those lines will always be the same distance away from each other. That makes those lines parallel, and parallel lines are always going to have no solution. Next, I have to figure out which method would be best to solve each system of equations. In my first system, I have y equals 1/4 x minus 2 and y equals negative 3x plus 30. In both of these systems, I notice that y is by itself, and they're both in the form y equals slope times x plus a y-intercept. Because of that, graphing would be the best method to solve this system. Next, I have negative 2x plus 4y equals negative 8, and x equals negative 3y plus 2. If I look, I notice that neither of them have y by itself, but my second equation has x by itself. Because x is by itself, I could take what x equals, which is negative 3y plus 2, and plug it in for x in my first equation. That means that substitution would be the best method. Finally, I have 4x minus 2y equals 36, and negative 4x plus 5y equals negative 22. I notice that neither of these equations have a variable that is by itself, but I do notice if I look at my coefficients, my coefficient of x in my first equation is positive 4, and the coefficient of x in my second equation is negative 4. Because these are opposites, I know that I could add both of these equations together and I would get 0 here, which means I would eliminate my x's. So elimination would be the best method to use for that system. For the next part, you had to figure out what type of correlation each of these variables had. Whenever I'm finding correlation, I always want to look at what the first part is, and I ask myself, as this increases, what happens to the second variable? So the first problem says a person's shoe size and the number of books they read last year. So I would ask myself, as a person's shoe size increases, what happens to the number of books that they read last year? Well, I don't know that the number of books that a person read last year would increase or decrease based on their shoe size, which means I would say that this has no correlation. Next, I have the number of hours that Jeff studies and his science test scores. So I would ask myself, as the number of hours that Jeff studies increases, what happens to his science test scores? Well, more than likely, his science test scores will increase as he studies more. So because both of those are increasing, I would say that this has positive correlation. Finally, time spent cleaning each week and the number of pests in a house. So I would say, as time spent cleaning increases, what happens to the number of pests in a house? Well, probably if we spend more time cleaning, the number of pests in the house are actually going to decrease or get lower. So because one of these variables is increasing while the other is decreasing, we would say that this has a negative correlation. Now let's look at our scatter plot with our line of best fit. The first thing we need to do is find the equation of the line of best fit. And so we know that when we find the equation of the line of best fit, we're always writing it in the form y equals mx plus b. Well, we need to figure out what m equals, and m stands for slope, and we also need to figure out what b equals, and b stands for y-intercept. The easiest thing to do here is to figure out our y-intercept first, because when I look at my trend line, I can see that it intersects my y-axis right here at 24. So that would make my y-intercept positive 24. Now I just need to find my slope. And I noticed a few of you had some trouble with your slope, so let's look at this. I gave you a hint to try the point where x is equal to 5. So if I go to my x-axis and I look where x is equal to 5, it's right here. So when I go up to my graph, I notice that there's a point right here at the line. And this point is where y is equal to 48. Now, whenever I'm finding my slope, it's going to be rise over run. So I need to count how far I rise. A lot of you noticed that you went up 3, and so you put 3, and then you went over 5, and so you put 3 over 5. However, you need to be very careful, because if you notice, each of these is not going up by 1. Each of these is actually increasing by 8. So I'm going up 8, then 16, then 24. So because I'm increasing 24, my rise is actually 24, not 3. Then I'm moving right, so I'm increasing on my run, and I'm moving 1, 2, 3, 4, 5. And those are moving by 1 each, because if I look at my intervals on my x-axis, each of those is increasing by 1. So my run is positive 5. Now, yes, that is an improper fraction, but we can leave it that way. So I would just leave this as 24. I know it looks weird to write it, but that's how we would write this one. Next, we have to use our equation to estimate the value or the number of dollars earned of a person who works 15 hours. So I'm going to use my equation, which was y equals 24/5 x plus 24. And I want to know what someone would earn if they worked for 15 hours. Well, if I look at my x-axis, x represents my hours worked. So I know that my hours worked are going to be 15. So what I'm looking for is y, my dollars earned. I'm going to plug in 15 for x, so this is going to be 24/5 times 15, and then plus 24. When I do 24/5 times 15, or times 15 over 1, I get 72, so this is y equals 72 plus 24. Now I'm just going to add 72 and 24, and I get y equals 96. That means that if a person works 15 hours, they can expect approximately $96. Finally, you have your two-way table. And on this two-way table, you have to determine each of the missing values, and then you have to answer the 2 questions at the end. So when I'm looking at a two-way table, I always try to find one place where I have all but one, either a column or a row where I have all but one answered. Well, if I look at my English column, I notice that I have 20 girls who liked English, and I have a total of 38 who liked English. So to figure out how many boys liked English, I would do 38 minus 20, which gives me 18. Now if I go to my math column, I notice that 13 girls like math and 15 boys like math. So to find the total who like math, I can do 13 plus 15, and I would get 20. In my science column, I don't have enough information to fill these out, so I might want to go to my rows. Well, if I look at my rows, I know I have 20 girls who like English, 13 girls who like math, and I know that there was a total of 50 girls surveyed. So to figure out how many like science, I could do 50 minus 20 minus 13. And when I do that, I would get 17. So that means there are 17 girls who like science. Now that I have that, I can figure out how many boys like science. I know that there are 40 total people who like science, and 17 of them are girls. So to figure out how many are boys, I would do 40 minus 17 and get 23. Now if I look at my total row, I notice again, I don't have enough information to fill out these. So I'm going to look at my row here of boys. Well, I know I have 18 boys who like English, 15 who like math, and 23 who like science. So to figure out how many boys I surveyed, I'm going to do 18 plus 15 plus 23, and that gives me 56. Now for my total, this is the total number of people surveyed. I know that I had surveyed 50 girls and 56 boys, so that means I surveyed a total of 106 students. Next, I'm going to answer these questions. So how many boys chose science as their favorite class? Well, I'm going to go to the boys row and figure out how many chose science. So I'm going to go to the science column in the boys row, and that is 23 people. So 23 boys chose science as their favorite class. Next, how many total people were surveyed? Well, if I go to my total and total, I know there were 50 girls and 56 boys, but that means there was a total of 106 people surveyed.